All right, ladies and gentlemen, in this video, we are going to be looking at how to predict the products for a single replacement reaction. And we're going to be looking at a very specific kind of single replacement reaction, that is a metal replacement reaction. The reason why these are called metal replacement reactions is because in every single one of these cases, the metal is going to be replacing the metal. As a reminder, in the periodic table, if we separate right along that staircase, everything to the left are metals. And metals in ionic compounds will always have a positive charge. They will always be cations. Now, to do this work for single replacement reactions, you need to have your periodic table and you also need to have your polyatomic ion sheet available. Both of these can be found in the documents within Google Classroom. All right. Now, because these are metal replacement reactions, I'm going to review again real quick that the metal replaces the metal. So on the product side, we end up with sodium and oxygen put together, and we have magnesium now all by itself. Single replacement reaction. Now, it's very tempting right now to think that you're done, right? You've replaced the metal, you have a chemical compound on the product side, you have magnesium all by itself. However, we need to remember to use those charges in order to come up with the correct chemical formula for the products. Sodium is going to have a positive 1 charge and oxygen is negative 2. Just as a brief reminder, here's sodium, plus 1 in that first column. Here's oxygen, minus 2 in the last column. In order to get this thing equal to 0 then, we need to have a second sodium. This allows us to have a negative 2 from the oxygen, a positive 2 from the sodium, ends up with the overall charge equal to 0. And again, that's because these two sodiums makes a positive 2. Get rid of the work that we don't need in our final answer, and then we're done. Let's do the next one. Aluminum is going to switch places with this copper. I'm going to fix this copper just a little bit. There's copper. And we can see then aluminum now goes with chlorine and copper is all by itself. Notice that I did not bring this subscript over. That subscript is not going to be the same on both sides. It might be, but not always. We have to use the charges to come up with that. Aluminum plus 3 chlorine minus 1. Brief reminder of where those come from. Positive 3 right here. Chlorine is minus 1. We need to have then 3 chlorines. Now, something that I want to address real quickly, just like I have in the other videos. A very common concern that students have when doing these is that we start with 2 chlorines on this side and we end with 3 chlorines on this side. How is that possible? Now I want to say 2 things. First of all, yes, it is possible. Second, we are going to be dealing with that next unit to explain how and why this occurs. Right now, you just need to remember that you must use the charges to come up with this chemical formula. All right, next one. Potassium is going to switch places with the calcium, so we end up with potassium sulfate and calcium metal. Now I want to address this guy right there, that sulfate. I just told you in that previous example that these subscripts don't get carried over because they might change. However, if we have a polyatomic ion, that is a package that has to stay together. It cannot be separated. The way that we can identify polyatomic ions easily is if we have oxygen in a chemical compound where there's more than 2 elements. So we have 1, 2, 3 elements, and we have this one with oxygen. That means that this is going to be a polyatomic ion. We're going to have to go to our polyatomic ion sheet to find it. There's the SO4. It has to stay as that package. The SO4 cannot change. So that's why this stays as the SO4 on this side. And we can use our charges to figure out the overall correct chemical formulas. So potassium is going to be +1, and then the sulfate's going to be -2. Real quick, here's potassium +1, and then sulfate, we have to go to the polyatomic ion chart. There it is, -2. There is the 2 there, so we have a +2 from the potassium and a -2 from the sulfate. Get rid of our work. And we have our overall answer. Very last one. As you can see, they get a little bit more difficult as we go. The magnesium switches places with the aluminum, so we end up over here. Magnesium nitrate and aluminum all by itself. This is the easy part. We identify aluminum. Aluminum is getting replaced, so it's all by itself. Magnesium slips into its spot. This subscript does not get carried over, just the individual package. So this NO3, that gets moved over, but that 3 on the outside does not. That tells us how many of that package there is. We can use the charges to come up with the correct chemical formula. Magnesium is +2, and then nitrate is -1. Quick reminder, here's magnesium +2, and polyatomic ion sheet, here is nitrate -1. There is no other way to be able to identify what the charge is on these other than looking it up or memorizing it. You will not be required to memorize these for the test. You will get to use this polyatomic ion sheet on the exam. All right, we need to come up with the correct chemical formula for these products then. Aluminum is just fine all by itself. Oops. We need to have a second nitrate here. So there's the second nitrate. Again, we need that second nitrate to get the overall charge equal to 0. We have a magnesium charge of +2, so we need to have a -2 from the nitrate. By having 2 of them, we end up with a -2 charge. Okay. Get rid of our work. Have our final answer, and we have 5 to try on your own. So go ahead and try these 5 on your own. Put your answers where they belong, and I'll grade them when you're done.